Okay, so we're going to go through your end of year paper. So the first question is, how many hydrogen atoms are there in 2 moles of that molecule? So if we have 2 moles of that whole molecule, each molecule has 2 atoms of hydrogen in it. So that means we're going to have 4 moles of hydrogen atoms. We've got Avogadros, but obviously we don't have our calculators. So I'm just going to look at this first number. So 4 times 6 is 24. So that would be 24 times 10 to the 23. Okay, or it would be the same as saying 2.41 times 10 to the 24. Okay, so they're trying to trip you up here by putting what could be moles here. And this would be if you forgot to times the 2 moles by 2 for each atom. The second one, which combination would create the strongest ionic bond? Well, you want the ions to be as small as possible, so there's less shielding and less effects from things like that. So, and then you want the charge on the ion to be as high as possible. So, for example, Na2 plus and Cl1 minus is going to have a weaker attraction than Mg2 plus and O2 minus. Okay, so that's going to be C. Question 3, which compound contains both ionic and covalent bonds? So obviously ionic, it has to have a metal in it. So B doesn't have a metal in it. So this is going to be a negative ion and a positive ion. K2O is just going to be ionic, so it's not that. And KACl is just going to be ionic. So this first one is going to be a covalent structure, say, with an ionic bond. So it's going to be A. Question number 4. Excuse me. So you're looking for multiple non-metal atoms for there to be covalent bonds, and then one metal atom to form that ion. So here we've got some different molecules here. What I would do is draw them out if I wasn't sure. And then the same molecules, just in all different orders. So we've got CH3, CH2, CH2OH. Then we've got CH3, CH2, CHO, which remember means it's an aldehyde. And then we've got CH3, COOH. So we've got an alcohol, an aldehyde, and a carboxylic acid. So the alcohol, what are the intermolecular forces? Remember, if we're boiling them, we're separating one molecule from another. We're not breaking the bonds within the molecule. So we're looking at intermolecular forces. So this first one is going to have hydrogen bonding. So it's going to be pretty high. The second one, we've got a delta positive, delta negative bond there, but no hydrogen bonded directly to oxygen. So that's going to have dipole, dipole. And the carboxylic acid has hydrogen bonding, but within that molecule it also has dipole-dipole. So it almost has twice as many bonds, if that makes sense. Even though the dipole-dipole is weaker, it still makes it higher than the alcohol. So this is the carboxylic acid is going to be the highest, followed by the alcohol, followed by the carboxylic acid. So we need because it's greater than at the right, we need the carboxylic acid at the top, so those two are definitely wrong. And then we need the alcohol next, so it's going to be B. Next question, which alcohol is the least soluble in water? So they've all got the same functional groups, so therefore the bigger they get, the less soluble in water they are. So it's just going to be D. Question number 6, what is the name of the substance using IUPAC rules? So again, feel free to draw these molecules out if it's helpful to you, because sometimes it's hard to envisage the molecule when you've not got it written down that way, or when it's 3D, so you've got the bond angles involved, or it's a structure you're not used to seeing. So we need to find the longest parent chain. Now, the parent chain has to have the alcohol coming off of it, so it has to have this carbon involved here. So what's the longest chain with that involved? So we go to here, and then that's got 3. It doesn't matter whether you go that way or the other way, it's going to give you the same name. So we have our alcohol functional group, and we have an ethyl functional group. So we need to work out our numbering. So we can either have 1, 2, 3, or 3, 4. So we can either have 2, 3, or 3, 4. So it's going to be 2, 3. So it's going to be 2-ol. So straight away I can see it's C. It's going to be 3 ethyl, pentan 2-ol. Next one. Which pair of compounds are structural isomers? So remember, a structural isomer, they have to have the same molecular formula, so the same number of each atom, but a different structure. So for structural, we're looking positional, so the functional group in different position. You're looking for functional group, so different functional group, or chain. So side chains being added on. So for example, butane becoming methylpropane. So you've got propane and propene. Now you could draw them out, but I know that they have a different general formula, so there's no way they can have the same molecular formula. Propanol and propanone, they've basically got the same functional group, so they should have the same number of atoms. They're just with an aldehyde is on the end. So they've both got 3 carbons, 6 hydrogens and 1 oxygen. So that would be effectively a functional group, although it's almost like a positional. So that actually is. Propan 1-ol propanal, well, you can see just from looking at this aldehyde here, it's not going to have the same bonds as an alcohol, because an alcohol is going to have another bond on here because it doesn't have the double bond. So that wouldn't be right. They would have a different molecular formula. Propanol propanoate is going to have 6 carbons, and propanoic acid is only going to have 3. So it's definitely not that. Okay. Number 8, what is the slope of the graph? Okay, so here we're working out the gradient of the line. Well, first of all, I can see the units are different. So I'm going to cross B and D out because the units are wrong. So it's either going to be 0.0025 or 0.0033. So it's going to be 0.15 over 60. There's going to be a 5 in that division even before I work it out. But obviously 15 fits into 64 times, so it's going to be 0.0025. Okay, so you can either work out that it's going to be a quarter, so it'll be 25, or the fact that it's divisible by 5, not 3, so it's going to be A. So once you cancel out those units, it's a bit easier. So don't sit there and try and do long division or anything like that. Usually the numbers are pretty self-explanatory or can fit into each other, or you can work it out through logic rather than mathematically per se. Number 9, which combination is correct? So we've got structural and empirical. So remember, the empirical has to fit directly into the structural. So this is a 2-to-4 ratio. So 6-to-12, that would work. 3-to-7, 6-to-14, that would work. CH, yep. C4, so D wouldn't work. So we don't even need to worry about what the IHD is. And then, so their structural and empirical could work. So then we need to look at the IHD. And as we don't have nitrogens or oxygens, we don't need to worry about the sort of more complex formula. So we're looking at 2C plus 2 minus H. Think about the general formula of alkanes is quite helpful. So for the first one, excuse me, the empirical formula. So 2 times 2 plus 2 is going to be 6 minus H, so minus 4 is going to be 2 over 2 is going to be 1. So this means A is correct. This would be half and this would be 1.5, so it wouldn't work out. It's actually an error on the mark scheme there. The mark scheme says B. So I need to add your mark on. Let me know if you need to add that on. Apologies. So number 10, the 2 containers that are shown are connected by a valve. What is the total pressure after the valve is released? So this is quite complex. So we're really looking at the idea, the gas laws, so that the pressure times the volume is the pressure times the volume. Now this is quite complex given we don't have a calculator, so you have to sort of think about it in more logical terms. So we would actually need to do this for both containers and then add them up. So if we look at container 1, the pressure is 2.0 times 10 to the 5. Now, because all these numbers are times 10 to the 5, I'm actually going to ignore that. So I'm just going to do 2 for the pressure times 4. So that's going to give me 8, but obviously it's 8 times 10 to the 5. I'm going to do the same for the other container. So the other container is 3 times 10 to the 5. So I'm going to do 3 times 2 is going to give me 6 times 10 to the 5. Okay, so that's my P1, V1. So that's my left side of the equation for each one. And then my volume, my new volume, is going to be 6 times 10 to the 5. So you're going to do divided by 6 times 10 to the 5 divided by 6 times 10 to the 5. So 8 divided by 6 is around 1.3. And I'm going to look at these numbers. It's not 0.5 or 0.0. So I'm going to assume it's 0.3 without spending too much time working out. 6 over 6 is 1. They're both times 10 to the 5. Okay, so what is our new pressure? It's 2.3 times 10 to the 5. So that's going to be B. So quite a complex question, but effectively you're using quite simple math in the end, so long as you're ignoring the standard form, because they all have the same standard form. But like algebra, you can almost like cancel it out. Number 11, how many p orbitals are occupied in a phosphorus atom? So phosphorus is 15 electrons. So give me 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so how many orbitals are occupied? Well, if this is 6, that's 3 p orbitals. And this is 4. So it's going to be 1, 2, 3, 4. Okay, so that's going to be actually all 6. Okay, it doesn't matter if it's half occupied, it's still occupied, it still has an electron in it. Which molecule has the weakest nitrogen to nitrogen bond? So N2, and you can do dot and crosses if you're not 100% sure, but nitrogen makes 3 bonds. So that's going to be N2. Then the next one, N2H2. So I can literally just draw the atoms in. I know there's going to be single bonds there. Nitrogen forms 3 bonds. And again, I can do dot and cross and work this out. It'll just take me a bit longer. And N2H4. I know each of the hydrogens is going to be a single bond. So that leaves nitrogen with 1 bond left. So that's basically a triple, a double, and a single bond. And then in the next one, we've got a double bond. So which is going to be weakest? The single bond is going to be weakest. Okay, so it's going to be C. Because remember, single bonds are longer and weaker. The more electrons you're putting into that bond, the stronger they're at pulling and attracting the nitrogen in. Excuse me. Along which series is the bond angle increasing? So they're all the same molecules, just in different order. So I've got NH3, and again, you can do dot and cross to work this out if you're not confident with the molecules yet. You've got H2O, don't forget all your lone pairs in there. And you've got CH4. I can use your valence electron numbers and divide it by 2 and work it out with the little lines like we did before. So tetrahedra has a bond of 109.5. Add 1 lone pair and it decreases by roughly 2.5, so 107. Sorry, that was 107. Apologies, the phone rang. So then the next one, another lone pair, so we'd minus another 2.5 from that, so it's going to be roughly 104.5. Okay, obviously I can also see that it's got 1 lone pair, 2 lone pairs, so I know it's going to decrease because the lone pairs are closer to the atoms, so they're going to repel and push those bond angles smaller. So CH4 is going to be the highest, so I can cancel B and D out. Then it's going to be an H3, and then it's going to be H2O. So number 13 is C. 14, what is the resulting concentration in moles per decimeter cubed when 1 centimeter cubed of 0.5 mole nitric acid is diluted to 50 centimeter cubed with water? Okay, so we're using our C1V1 calculation here. So that might be what you start with, and that's what you want to get. For example, So we start with 1 centimetre cubed divided by 1,000 is 0.001 and 0.5 concentration. And then C2 is what we're trying to figure out. And so it's divided by 50 divided by 1,000, 0.05. So 0.5 times 0.001 is going to move it by 3 decimal places. That's going to be 0.0005 over 0.05. 5 over 5 is 1, so it's going to end in 1. So the way you can think about it is 1, 2, 3, 4. It's going to be 5, 1, 2, 3, 4 over 500. It's going to be 0.01. Okay, what is the name of this compound applying IU-PAC rules? So looking at the longest chain, that's going to be the longest chain, so we've got a methyl group there. So I can get rid of my ethyl one straight away. So I have 1, 2, 3, 4, 5, 6. Double bond takes priority. So it's going to be 2-hex-2-ene. So I don't need to go any further. Number 16. What is formed in the propagation step, the substitution reaction between bromine and ethane? So bromine is going to form 2 free radicals. And then that free radical will react with ethane, CH3, CH3. So we're always going to get HBr or HCl or whatever, plus your free radical, so CH2, CH3. So it's going to be A. We can never form C. And D we can never form either because it's a negative ion, not a free radical. So it would have to have had both electrons. And we can't form a longer carbon chain. So actually I could have done it without even working that out. Number 17, which monomer would produce the polymer shown? So you're going to draw the same molecule, just with a double bond. So those 2 side bonds become a double bond. So I would write that as CF2, C, CLF, doesn't matter about that. So CF2, so there's CF3, so that's wrong. So it's going to be CF2, CCLF. Let me see. Okay. Next question. So number 18. So burette readings. So let's work this out. Oh, this was quite a mean question. I remember going over this. But it's a good one to practice because it'll stop you getting tripped up in the real exam. So 11.35 minus 0.2 is going to be 1.5. 24.60 minus 13.50 is going to be 0.10. That's 11. And then 11.20. So obviously the mean of those 3 numbers, they're all concordant because they're all within 0.01 of each other. So we can use all 3. The mean is obviously going to be 11.15. Now, because we take 2 readings to get our final result, that means we're going to get that error twice. So our error is 0.1. So I'm going to cancel these out straight away. The temptation is obviously to go for B because that seems to be the only correct answer. Now notice A and D have been rounded up to 1 decimal place. So this would become 11.2, so it's D. So be really careful about that. If it was 11.20, it would have been incorrect. But what they've done is they've rounded it up, but they've expected you to realise this is wrong by the error. So pretty mean question, but just keep an eye out for that. Make sure you're paying attention to all the different parts of the question. Number 19, what is the coefficient of HCl? And the equation is balanced, so... Okay, so there's my equation balanced, 1, 1, 1. So what would be the coefficient of HCl would be 2. So it's B. Number 20, what is the relative molecular mass of bromine. So if I'm talking about the molecule of bromine, it's a diatomic molecule, so it forms Br2. So we're not looking at this part of the they're single atoms of bromine, so we're only interested in the molecules of bromine. So remember, to find out your RAM, it's going to be mass times abundance plus mass times abundance, and that again for this one, divided by your total percentage. And be careful, it's not always 100. If we look, this peak itself is 100. So it would be 158 times by 52 plus 160 times 100 plus 162 times 48 over 1900 over 200. Okay, oh, actually they've put them separately. So over 52 plus 100 plus 48. So then I'm looking at what matches this. So it's going to be number 1. It's going to be A. Number 1. It's going to be A. If I look at B, B has put the masses on the bottom, not the percentages, so that's why that's wrong. C has included the individual atoms, but we just want the molecular mass. We want the mass of the molecule. And D has only done the atom, so this would be the RAM of bromine atoms. Okay, this is the RMM or MR of Br2, and the other two are just wrong. Number 21, which species has the same electron configuration as argon? So argon has 18 electrons. So Br minus is going to have 36. Ca2 plus is going to have 18. So that looks like the right one to me. Just double check. Al3 plus is going to have 10. So remember, I'm minusing electrons for the positive ions and adding electrons for the negatives. Silicon's 14. I suppose 10 as well. This is going to be. Could sit and work out the electron configuration, but that's going to take a lot longer. The next one, so we've got the Lewis structure of methylamine. What is the molecular geometry around N? So I'm basically only interested in this molecule. So what is that shape? Well, it's got 3 bonding angles and a lone pair. So it's a triangle, and it's going to be a pyramid because the lone pair is pushing those 3 down. So it's going to be trigonal pyramidal. And if I was to draw it out as it is, ignoring what else is bonded to the carbon, it would look like that, if that helps. 0.2 moles of magnesium is mixed with 0.1 HCl, which is correct. So your Mg2HCl should be a 1:2 ratio. If I've got 0.2 of this and 0.1 of this, I've got it the reverse way around. So I do not have enough HCl, so that is your limiting. Okay, and then what is the maximum of H2? So I would use the moles of my limiting to work out H2. So it's a 2:1 molar ratio for H2. So 0.1 divided by 2 is 0.05. So that's C. 24, what is the formula of a compound formed from Ca? So remember, these ionic compounds has to be neutral. Okay, it's not a charged particle. So I basically need to make it equal 0. So I can sit and add it up and work out how many of each I need to make the charges 0. Or if I cross them over, I automatically do 2 times 3 minus is 6 minus, 3 times 2 plus is 6 plus. So you can see it automatically cancels them out and makes it 0. So we have Ca3, PO4, remember because it's a complex or polyatomic ion, all of that is times by 2, so I use my square brackets, so it's going to be B. Which is the correct order based on increasing strength? So obviously bonds are stronger than intermolecular forces. And in your intermolecular forces, your strongest is hydrogen bonds, incorrectly called because they're not really a bond. Dipole, and then London dispersion forces. So the strongest needs to be on the right. So A and D are wrong. So then we've got hydrogen bonds, which is right. And then we've got dispersion forces and dipole, so it's going to be C. Which monomer forms from the polymer shown? So you're looking, where does it repeat? It has to have at least 2 carbon atoms because it's formed from an alkene. So it has to have a carbon-carbon double bond. So I've got ClH. So that is my repeating unit there. So my monomer would be those 2 carbons double bonded, looking what they're bonded to. So CH3 and H, Cl. So if I was to turn that into condensed structural formula, CHCl, double bond, CHCH3, and that can be, those 2 can be in brackets, they don't need to be, either way works fine. So B and C are clearly wrong, and D, just checking, yeah, it looks like they've done it the wrong way around, but the second part is wrong. It's definitely A. Which is a propagation step for the free radical substitution? Well, A is an initiation step, so it's definitely not A. And then looking at any of the others before I sit and actually work it all out, B could possibly be a real propagation step because it's got 1 free radical on each side and all the compounds can exist. C is a termination because you're doing 2 free radicals to no free radicals. And D, we can't produce a H free radical, so I don't even need to work it out, it's B. Okay, if then I couldn't cancel it out any further, then I would actually sit and work the mechanism out, which there would be. 28, which spectra show the difference between propan-2-ol and propanal? So with these kind of questions, often I would draw the structure out first. So I've got propan-2-ol, propanal, draw propanone. Okay, so mass spectra, this has 3, this is C3H, 3, 6, 7, 8, O, and this is C3H, 3, 4, 5, 6, O. So there would be a difference in the mass. So yes, mass spec would show us. Infrared, it shows us function group. So this one, it would show a broad OH peak, and this one, it would show the strong COO peak. So that would tell us the difference. And HNMR, this first molecule is symmetrical, and the second one isn't, so they would have different environments. So all 3, so the answer would be D. 29, what is represented by 2 minus? So it's gained negative electrons, so it'd be B, gain of electron. I mean, technically it's 2, but gain of electron. Last question, how are emission spectra formed? Photons are absorbed when promoted electrons. So the absorption spectra would be A and B. So I'm going to cross those out. So photons are emitted when electrons are promoted to a higher energy level, when protons return to a lower energy level. So they take a photon in and jump up and get excited. So the photon is going in. When they fall back down, they give that photon of light back out. So it's going to be D. Okay.